we're going to take a look at the ambiguous case of evolved signs. And so the ambiguous case arises when we have a side, and an angle. And the reason it occurs is that because when we're starting to find that second angle, okay, and the second and third angle, one might be obtuse or one might be acute. Okay. And so that's where we have to make sure that there is possibility that more than one triangle could be constructed. So take a look at this. Suppose we have these conditions. A is equal to 40 degrees, side A is 54, side B is 62. There are two possible triangles for this. Okay, so if we were to go through and try to find this missing angle right here, okay, for C1, given these conditions, all right, one set would be 40, 48, and that would be 88. And so if we subtract 88 from 180, that should be 72 degrees, okay? Um, Now, over here, we have another scenario that C could actually be extremely small in this case, okay? If B happened to be an obtuse angle, okay? So we know that if this was 40 and 132, that the remaining degree here would be 8 degrees, okay? And so both of these conditions are satisfied, okay? Notice that C2 would really be small. And so that just means that because when we find the reference angle for this, okay, we have to make sure by the law of signs that there are no other triangles, or if there is, that we solve these. Okay, so what we're really going to do is we're going to solve for one of the missing angles. Okay, then what we're going to do is we're going to see whether or not that if it's complement, if we take the reference angle in quadrant 2, if that angle and the given angle add up to less than 180, that means there's going to be a second triangle. Okay, so I'll show you this process in a few moments when we go through and do one of these. Okay, but that's the whole genesis for this. Now, this is only work when we have side angle. Okay, if we have side angle, there's only one possible triangle. Okay, because there's only a third triangle that works for that. Okay, given that the possible scenario is feasible. All right, there's also a case where there could be no triangle. Okay, so in other words, I might give you information and we just don't fit within the domain. All right, so let's take a look at a couple examples to where we have this ambiguous case with an angle and two sides. And let's see if there's no possible triangles, or two triangles, or even one triangle. Okay, because that still is a possibility. So we have side A is 85, or angle A is 85 degrees. Side A is 15, side B is 25. Using the law of sines, I can say that the sine of 85 degrees, okay, which is A, divided by side A, which is 15, is going to be equal to the sine of B, which is unknown, divided by 25. Right? So if you're looking for an angle, put the angles in the numerator. If you're looking for a side, put the sides in the numerator. I can multiply both sides by 25. So I get 25 sine of 85 degrees divided by 15 is going to be equal to the sine of B. I'm going to compute this expression. Okay, so I'm just going to go on my calculator and I'm just going to figure all this out. So we have 25 sine of, I think it was 40 or 85, excuse me. Okay, so 85. I'm going to divide that by 15. So I get 1.66 approximately. Okay, so I get that 1.66 is equal to sine of B. We know that to solve, we just take the arc sine. Okay, so if we want to solve for angle B, we just take the arc sine of that. And if we go into our calculator and try to find the arc sine, okay, so we take our sine minus 1 of 1.66, okay, notice that's undefined. Whether it's radian or degree mode doesn't matter, all right, because this is outside of the domain for the sine function. Okay, remember domain is negative pi halves to pi halves is, if we were to go in here, pi over 2 is 1.57. Okay, or so unfortunately, or I'm sorry, that's going to be the range for it, for the output for it. But unfortunately, we can't throw in anything that's going to be any greater than 1 or any less than negative 1. Okay, so that just means that in this case, there is no possible triangle. Okay, so we have that this value, okay, since x is greater than 1, there is no triangle possible. Okay. All right, a second example. We have A is 58, and then side A is 42.2, and then side B is 50. So since we're looking for an angle, I'm going to say that the sine of 58 degrees divided by side A, which is 42.2, is going to be equal to sine B divided by side B, which is 50. We can multiply both sides by 50. So 50 sines of 58 degrees divided by 42.2 is equal to sine of B. I'm going to compute this mess, okay, by just throwing it into my calculator. And that's going to be 50 sine of 58. And we're going to divide that by, or 50, excuse me. Oh no, 58 degrees. So 50 sine of 58 divided by 42.2. Okay, and make sure 42.2. That gives us 1.005. All right, so that's going to be 1.005 is equal to the sine of B. We would take the arc sine, or try to, of 1.005. All right, and that's going to be equal to B. But notice that this interior value is greater than 1. Okay, so if we have any value inside of there that's going to be greater than 1, we're going to say that there is no possible triangle. Okay, all right, so that's the first of the two ambiguous cases where for some reason we get no possible triangle out. Okay, now in the last video, I'm going to show you two examples where we can get two possible triangles. Okay, and so those are going to be a little bit longer and tougher. These are fairly easy, just because you can find it right away by setting it up. All right, that there's going to be no possible triangle. So we'll see the ambiguous case, the final portion in the next video.